It's nowhere in the contract.
Oh,
If it was, I would boycott the shit out of that.
oh yeah. You got some on top of me as a professor.
But I see the utility in Canvas as at least a repository of stuff.
I agree. Having taken several online classes, I am a big traditionalist. I want to be here in person.
So this is up there, and if you go into Canvas, and if you go to modules, very first module is final exam stuff. Let me become a student. There we go. Practice final answer key. In the middle of that is the final exam week schedule. So what I've done, so our final is Wednesday, yes? So next week is just a normal week of classes, except every class is going to be a final. So I've added office hours. So anytime I have extra office hours, as in addition to the office hours I already have. You guys with me? So like Monday, I'll be in my office from 12 to 2, basically 12 to 1:30, and then supposedly I come down here. Normally I forget what time it is, I'm still in my office. Wednesday, I've got the same kind of idea right before, so I got a 2-hour block of office hours before our exam starts. You with me? Okay, if you need those last minute questions answered. Anyway, so you guys can look through all that. If any of you still need to make up a test or something, I don't know if anybody's in the boat, then you could pick one of my final exam times and just tell me you want to take something in. So I don't think, if anybody needs to make up test 3, for example, or something, then you could make it up next week. Does that make sense? Okay. I think that's all I want to show you in here. Yeah, that's the most I use Canvas for, so that makes sense. Okay, any questions on that? Sweet, I like it. So, any questions on, let's do this. I want to talk a little bit about new stuff with Chi-Square, and then I kind of want to start our final exam review early, and then we'll finish up final exam review on Monday. So Monday will be devoted to final exam review. Can somebody tell me where I put my pen? Oh, can somebody tell me? Huh? No, my other pen. There it is. What's up? I was gonna say that would be amazing. There we go. How dare you? Go home, Cameron. You're drunk. Okay. All right. I am almost certain that I completely forgot to bring a chi-square chart, but that's okay. You guys are going to help me. Does anyone know the formula for chi-square for a... Oh, thanks, Michelle. You keep it. I'll crowdsource some stuff, but you're good. Thank you. I've talked about 2 chi-square scores so far, 2 formulas. There's the one that's for goodness of fit stuff. Does anyone remember what that looks like?
O minus, where's it? E minus, no, it's O minus E squared over E.
And by the way, it really doesn't matter because the square would kill the negative if you had those turned around. I don't know if you guys are with me. That's the whole reason we square is to kill the negatives. So that is the one we used for the goodness of fit tests that we did last time.
Yeah.
If you weren't here last time, we're going to do an example of this a bit later. Okay. The other one that I put up here briefly was this guy. It just went right on my head. There it is. It's come back. This is the formula that you would use in a couple different situations. You would use this for a hypothesis test. So if my claim was the standard deviation is less than 3, if that was my claim. Is that the HO or the HA?
HA.
Yeah, standard deviation is less than 3 of the HA. So what would that look like in mathish?
Standard deviation symbol less than
Sigma.
Yeah, sigma,
Sigma less than 3.
less than 3. So what's HO?
Sigma greater than or equal.
to 3.
I love it. And then eventually, when you get down to step 3, that's the rejection region, right? So let me talk about this for a second. This is where I might have to actually borrow your sheet there, Marshall. So here's a chi-square distribution. It's not symmetric, correct? Okay. But I want you to see 2 reasons why the chi-square chart is broken up the way it is. This is where I would expect, somewhere in here is where I would expect an S to show up. So how am I going to test this claim? How would I test this claim? Wouldn't I take a sample? And I would calculate an S. Is everybody with me?
Yeah.
If this really is 3, I would expect the standard deviation of a sample to be close to it. Same kind of idea as with means and percentages. It just lives in a different distribution now. So if it's less than 3, which tail test? What side is the tail on?
1.
So one tail test over here, correct?
Yeah.
Okay, good. So let's say alpha is 0.01. And let's say I have a sample of, let's make it not too crazy, 25. Okay, let me stop for a minute. Degrees of freedom for a goodness of fit test is a weird formula, yes? What was the formula for degrees of freedom for goodness of fit?
K minus.
K minus 1, where K, of course, stands for, it only makes sense, categories. Okay. I just love that fact. Here, this is not a goodness of fit test, correct? This is a hypothesis test about a standard deviation.
Yep.
So my degrees of freedom go back to being nice and normal. Can somebody look up, what would the chi-square score be? Now here's where you gotta be careful. This is the one thing I want you to realize, yes?
Wait, why are you doing a chi-square number when this is a hypothesis test, not a...
I love it. It's a hypothesis test. It's a hypothesis test for means, Z or T, yes? For percentages, they live in a Z distribution if NP and Q is bigger than or equal to 5, yes?
Yep.
Standard deviations live in what kind of distribution?
No.
Standard deviations live in a chi-square. I need you, so the first day when I first introduced chi-square, a standard deviation tells me what a normal curve is shaped like. It has one standard deviation. And that tells you what the shape of plotting all the sample means or plotting all the percentages. It tells you the shape of what they all would be. It finally gets its own turn now. What if I take a bunch of freaking S's? I take a sample, get an S, take a sample, get an S, take a sample, get an S, and I plot all that shit. It's gonna look like that. Like that. It's not gonna look normal, it's gonna look chi-square. So standard deviations live in a chi-square distribution.
So that's why you're using it.
So if I'm going to test about it, I have to test it from a chi-square distribution, yeah. Here's why this is set up this way. This is exactly, so here's the middle. This would be the the left, there it is, Jeff, see big L? The left's tail. This would be the right tail. Do I have a left or a right tail test? I have a left tail test.
That is
So if I want alpha to be 0.01,
0.99.
it's 0.99 because this is the area to the right of it. So if alpha is 0.01, what's the area to the right of it? 0.99. So if I look up 0.99, degrees of freedom was 24, I would get this. You guys with me? 10.856. Okay. So this would be 10.856. So how do you define your rejection region? If chi-square is less than 10.856, we can reject the null,
and
support the hop. So the one nice thing about most hypothesis tests is they have the same structure. They use a different determination of whether it's normal enough. They use a different chart, ZT or chi-square, right? But they all have the same kind of 5-step structure. Like it, MIT. So just to kind of do this, so everybody's semi with me so far. So the hypothesis you set up the same way as always. You have a claim. If it doesn't have an equal sign, it's the hop. Same way as always. That's a one-tail test. Kick ass. This looks different than a T-score chart. T-score chart's really nice. It says one tail, two tail. Thank you, T-score chart. This one is more visual. If you're on that side of the distribution, you look on this side. If you're on that side, you look on this side. It's kind of nice in its own way. Okay, maybe yes.
So if you're looking at that one, you don't have to look at one minus the other thing because it's already on the right side.
Yeah, if you're looking on this one, yeah,
Right.
yeah. We don't have to do one minus whatever.
Okay.
I'm not exactly sure which part you're talking about, but yeah. Okay.
What if it was a two-tailed?
Yeah. Now, if it's a two-tail test, real quick. If I said alpha was 0.05, two-tail test, well, how much does each tail get then? 0.025. So you look at 0.025, you look at 0.975. The really nice thing about that is, do you see how it's symmetric?
Oh.
1, 2, 3.
Mm-hmm.
So ours is a one-tail test, so the entire alpha goes in that one tail. If I had a two-tail test, I would just cut it in half for both sides. So to be really honest, I like the fact that this chart's more visual instead of just, it says 1 or 2 on the T-score chart. This is the middle of the distribution. This is on that side, this is on that side. It's kind of nifty.
How would that work? Would you subtract the two chi-squares from each other once you found out what the two?
No, it'd be just like a two-tail Z-score test.
Oh, that's right.
Right, so if I have negative 2.576, positive 2.5, if it's outside of there, then I can reject it. Same thing would happen here. Yeah.
Could you go back to the solution, the ho and ha? I just want to make sure. No, at the bottom.
Oh. Same thing as always. Yeah, if we get into the rejection region, we can reject the null. Okay.
But that
So-
wasn't the claim though. The claim was the.
Well, I don't care. Hypothesis test is always trying to do the same thing. It's always trying to reject the null. The claim gets me started, and then I forget about it. And then it comes back at the end. In the middle of the problem, I don't give a shit what the claim is.
Forget about it.
So, I love you guys so much. If you just go with me for a little bit, I promise you'll like where we're going. We don't trust you. I understand. So let's say I take a sample of, what did I say, 25? And let's say I calculate a standard deviation of 2.7. Is that less than 3?
Yes.
It is. So why don't I stop? I found less than 3. Right? Then I get less than 3.
So you.
But it's not.
Why don't I stop? Why don't I just stop and go, I don't need you, test?
So that's S.
Yes, it's based on a sample. Not only does it have to be less than, it has to be less than enough, right? We've already set up the benchmark. So here's the benchmark. Here's my sample information, right? How do I calculate the chi-square? N minus 1 times S squared over sigma squared. What's N minus 1?
24.
24. S squared we know is S.
2.7 squared.
What's sigma?
We don't know yet.
We do.
We do?
It's 3.
Oh.
We assume it to be 3, just like we do with other hypothesis tests. Is that okay? What's that gonna be? 0.9. Somebody save me for myself, at least 2.4 times 8. I don't know. Is it 16, 17, 19.2? 19.2? It's probably not 19.2.
3.4.
What is it?
19.4.
Holy shit! I'm sorry. What I meant to say is I'm really sorry that I thought it was 19.2.
I'm just watching.
19 point what?
4.4.
Yeah, I suck. Alright. Jeff, you're off by so much. Alright, so in this case, would we have made it into the rejection region?
No.
Nope, because we're over here, yes?
Not even close.
Do we make it below 10.856? Nope. So then we fail to reject the null, fail to support the hop.
Were you reviewing this Monday or no?
What I'm gonna do, and I told you guys we were gonna like what I got. I didn't want to say this too early because then you guys wouldn't have paid attention. This section is gonna be extra credit. This is section 11.6, I believe. I would need everybody. I need a reaction. You understand what I just did? Section 11.6.
So,
And you
is
think
that,
Waller.
is that
I feel
chi-squared?
really weird right now. You know, like, yay,
You just got your
less for us to learn.
You
Thank
just
you.
got your math class applauded, that's a high point.
No.
Has that happened to you?
Is that,
Yes.
go tell the people that the teachers.
Not very often.
Is that a x squared chi, sorry, chi squared star? Chi
Yeah, we
squared.
call that.
Yeah, this is like chi-squared star. Yeah, yeah, chi-squared star, if you want to call it that. Yeah. But so I needed you to pay attention. I want you to understand. We could use the thing I want you to understand is the exact same way we do a lot of stuff with the normal distribution, with means and percentages. We can do all the same shit for standard deviations, but it has to be from the chi-square because that's where they live. So, for example, I could do a confidence interval for a standard deviation. I'm not going to, because you all know it wouldn't be something you could do. So maybe you'd all tune out. I wouldn't blame you. Yes.
But would this process change if we, for whatever reason, were using the population standard deviation rather than a sample?
Oh, I wouldn't do shit if I already know the actual population standard deviation. I'm not going to make a claim about it.
Okay. So this is only used to verify, get a bunch of sample standard deviations together, and then do this process to see where they fit.
So here I only took one sample, correct? Yeah. But it's just testing a claim about what the population standard deviation might be. So I don't know what it is. Yeah.
Could you do percentages of standard deviations?
Oh, no.
No.
So so what could a parameter be? The first day, a parameter could either be a mean or a percentage, because that's all we knew about. So now we understand a parameter could be mean, percentage, standard deviation, yes? Or to be really honest, we normally consider the variance. But standard deviation, are you with me? So those are the three big things that could be a parameter. To be really honest, the truth is it could be any value that could be true for the population that I could estimate with a sample. But those are the big three. Okay. So what I want to do for the rest of the time is I want to start a review for the final. Let me make sure, I didn't bring my book with me, but I'm pretty sure 11.6 is the section that has the hypothesis testing for standard deviations. Somebody have their book with them? I want to make certain. Can you look at 11.6?
Wait, so 11 though, that is gonna be on the test, just not 11?
Yeah, totally. So 11.2, if I remember correctly, is goodness of fit.
Right.
Yeah, we totally covered the shit out of that, so that's gonna be on there. Where the hell is the contents here? So 11.2, goodness of fit, yes. And 11.6 is the test. Kick ass. So 11.6, I think I have it, I'm sorry, I lost where it is. 11.6 is extra credit, right? Okay.
Yes.
Can you go for one more time where you did the reject the support the hawk for this problem?
The which one? Sorry.
For literally the one that you just did.
Yes.
If the standard deviation was greater than 10.856, write that.
Oh, if the chi-square
Chi-square, yes.
is less than 10.856, I would get into this rejection region. Right? Are you with me? If chi-square star, I guess if you want to call it chi-square star, is less than 10.856, and we looked that up in the chart, right? Then I'm in the rejection region. I'm far enough away from this middle where it should show up. If it really is 3, then it's evidence that it's less than 3. Same idea as before. So we actually made it, we didn't make it. We got to like right here, 19.44, so we didn't make it in there. So we didn't find evidence in support of standard deviation being less than 3.
So how would we word that into?
We have now found sufficient evidence to support the claim that the standard deviation is less than 3. It's exactly like what we did before, yeah. So just in case you're gonna do that extra credit, a lot of the stuff is exactly the same. The wording's the same. You're just talking about the standard deviation now instead of the mean or percentage. Yeah.
Well, the extra credit has a step, or maybe we should know that.
Oh, well, that's part of why it's extra credit.
Sure, yeah.
Okay. So you can try that out.
Formula sheet?
See again?
Formula sheet?
So I was going to ask you, part of what we could do today, we could go ahead and bang out the formula sheet, and then we can talk about a few things, and then we can do the rest on Monday. Cool. All right. I love it. Do that shit. Okay. So this is going to be, I kind of like doing the formula sheet first because this spurs some memories, or at least makes you go, I don't remember that shit, and then you're like, let's talk about that. So going way back in time, chapter 1. What was chapter 1 all about?
No idea.
Beautiful.
No.
Oh, no, population terms.
Yeah, it was all definitions basically, right? It did introduce the idea of frequency distribution, but we use that more in chapter 2. I like it. By the way, I always forget to talk about this problem. Let's see who remembers this problem. There's a problem way back in chapter 1, and it said there were 2 researchers with different groups of AIDS patients. And they said, what would explain the differences between what the 2 saw? And what I really love is when a student says, they had different frequencies. It's kind of like a cop pulling me over, and he says, why were you speeding? I'm like, because my number was big. So when it asks you why, it's not saying because I saw the numbers are different. No, why were the numbers different? So an answer would be something like, the 2 samples could have different aged people. It could have more one cisgender than the other. And of course, there's biological differences there. And medication can react differently. Are you guys kind of with me? So don't just go, because the numbers are different. No, the question is, why might the numbers be different, right? Okay.
So data variance and kind of broad term.
Well, yeah, and this is more just, they could be differently aged, they could already have other health issues that could affect how the medication works for them, all these kind of different things, okay. Okay, that's not terribly important, it just came to mind. Chapter 1, definitions. So, no contribution to the formula sheet. Chapter 2, histograms, box and whisker plots, percentiles. Right? This feels like a decade ago, maybe. I don't know. Or it feels like yesterday. I don't know. It's weird. So the first formula we ran across in chapter 2 were the formulas for the mean and the median and the standard deviation. We all know the mean formula, yes? You don't have to write that down. Median's not really a formula, it's a way to find it. Percentile is a method, it's not really a formula. Standard deviation formula, you don't have to know because I'm not going to make you do it again, right? This one, don't write this down. Remember that? Yeah. So now what do we use? We use one of our stats because I made you go through this, and now I'll allow you to use this. Okay. You guys all with me?
Is the median still high minus low?
No. High plus low divided by 2 would be mid-range.
No, not plus, minus, no.
High minus low would be range. Median is just the numbers in the middle. It's P50, right? The median would be P50.
It's what, Q2 or Q2?
All right, so let's go. Here's the first real formula we hit. We actually hit this formula back in chapter 2. We introduced the idea of a z-score. Huh? What's the matter?
No, it's fine.
Okay, all right. And of course that leads to this formula here, right? What else was interesting about this formula?
Oh, it tells you what the z-score is.
What the z-score is, and that's the question I'm always going to ask you, including on the final exam. I'm going to ask you, what does the z-score tell you? And I'm still not going to get. I don't even really get it anymore. But what's the z-score tell you?
The number of
Standard deviations from the mean
Oh, from the mean to the data point.
to the data point. Yeah, that's all it tells you. So it can't tell you an area because you looked at the z-score chart for that. So the z-score didn't tell you that. The z-score chart did. So z-score by itself, that's what it tells you directly. Is that cool?
Does it work both ways if you say it's the distance from the mean to the data point, or from the data point to the mean? It's the same value.
Same. Okay. Then we get into chapter 3. Chapter 3 was all probability. So we got all the standard stuff here, so probably A or B. Who remembers what that is?
No.
It shared the sentence. Like,
That's gonna be on the ST test?
Why would it be?
Isn't it? That was a long time ago.
Get
Isn't it A plus B minus B?
Something like that.
I like the
you know,
plus, because
the
or is
plus
basically N,
plus,
right?
Yeah.
A plus B to
So it's probably A, plus probably B, minus?
Probability of A. Of A, B.
A and B.
Yes. Because if it's both, I would have counted them twice. I like it. Very sorry if you were hoping this wasn't going to be on there. It very much is. And remember the given? It's okay if you don't, because I didn't make you memorize it. But
the B is on. No.
good.
And then can you do the vice versa one?
And then you got the and. Oops. We're trying to be B given A.
We do the other one.
What other one?
Where you have A at the bottom.
Oh, I see.
Oh, that's B given A.
Yeah, it's just, yeah. So if you want to, you can write it down. So that just really hammers home that the given is what goes in the bottom, right? Okay, let me stop for a minute. I know it's been a while, but does that look familiar at all?
Sure.
No. Randy's like, are you sure you talked about that?
I don't remember this at all.
I understand.
That's that top one. That's B given A, right? It's just a really thick line.
Yeah, that's alright.
All good. All good.
That's probably many times probably B given A.
I'm not critiquing you, Professor. Just verifying.
But I am.
I feel.
It's okay.
I'm judging your penmanship every day.
I judge myself all the time.
Oh,
I don't want you to be self-conscious. That's why.
No,
You
okay.
can finger.
Yeah, that's true. Fingers in the way.
No, sir.
Hey. Whoa. Yeah.
I'm such a dork. Alright. So that's chapter 3. So then we get to chapter 4. Anybody remember chapter 4?
Oh, binomial. Binomial?
Binomial is part of it. So let's do, it starts with the general probability distribution, so that was this guy. You guys remember that in the first 3 letters?
Summation of all x p.
Yeah, EXP is what it looks like, and that's because the other name for the mean is the expected value.
Wait, what's that for?
It's just a neat coincidence.
No.
What do you mean, what's that?
Yeah.
So when I give you an X and P of X table,
Oh, that's right.
that's how you calculate the mean.
Well, population. It's not the same.
Standard deviation. There's this stuff here. That's trying to be a mean, right? Let me give my little disclaimer. Double check your formulas because, you know, you've had me for a while. I'm sure you've noticed I don't write well. So you want to make sure that you actually wrote the right formula and not misinterpreted my writing.
That's
So double check your
p of
formulas.
x minus mu squared.
Yes, minus mu squared. This mu got a little excited, poor little dude. And then we got into, like Bessie said, we got into binomial stuff, right? That was the n choose x, p to the x, q to the n minus x. Okay. Then we had the best formulas in the frickin' universe for the mean and the standard deviation. Okay. So that's chapter 4.
That's a square root and PQ.
Chapter 5 was uniform distributions.
Rectangles.
Yep.
Oh, yeah, those.
No formulas.
I like those.
Sweet.
She's like, there's no formulas. That's why I like them.
Yeah.
Then chapter 6, of course, I'm sorry, go ahead. Chapter 6 was where the most important chapter in the whole class, because that's where we introduced normal distributions. Yeah. So that chapter 6 is where we really get into the z-score stuff. So you can write this again if you want to, because it's important. We did this again. You already have this, but it's up to you. Chapter 7 is where we started doing the central limit theorem, which was where we have this here. Right? So central limit theorem, one thing it said is the bigger your sample gets, the skinnier if you plot all the means, the skinnier that gets. Okay.
Is that standard deviation over square root n?
Yeah! Please tell me that's familiar. We've used the hell out of this, yes? Okay. Then we got the so that's chapter 6, chapter 7. We got to chapter 8. Chapter 8 is where we did confidence intervals. What kicks ass about these two formulas?
They're the same thing.
Same thing, but what does it tell you?
One
Whether
tells
we're
you
gonna
population,
sample
standard
or not.
deviation, one tells
It tells you when to use a z, when to use a t, yeah? Use a z when you know sigma, use a t when you know s. So if you catch yourself saying, I'm going to use z-score because I know the standard deviation, stop. Maybe you're right, maybe use a z-score, but your explanation is shit. It all depends which standard deviation do you know, right? And most often students will say that when they should have used a t-score because the standard deviation came from a sample. So be very careful about that, okay?
So what was the wrong wording on that? Just, because you know a certain standard deviation.
Because I know the standard deviation.
Oh, that's not helpful at all.
So it's all about which standard deviation, yeah.
Wait, this is chapter 8?
Chapter 8.
I don't know.
And then of course the other formula for confidence interval was this guy, the hatted ones.
Was there no formulas for chapter 7?
This is what's up? Sorry?
Was there no formulas for chapter 7?
Chapter 7 is right there. Sorry. I didn't put a line.
Oh, it's just one.
Chapter 6, chapter 7, yeah. Chapter 7 was about central limit theorem. So we take a sample and the standard deviation changes. Yeah. Then if you put over here, I think I would rather put over here, let's see. So for each one of these, they get their own little end formula, right? So this would be a question I would say, how many, so that's n, would you need to survey to be within so much of something, right? The within is the E, yes? Okay. See, we're in chapter 9. Chapter 9, everybody's favorite.
Yeah.
Is that hypothesis test?
Hypothesis
Those are the
test.
only buckets really.
Is my camera going?
Yes.
Thank you. Actually, remember to recharge the battery for us.
What's the E in this one again?
Down here?
Error, right?
Yes, error, but the key word would be how many would we need a survey to be within 11, then E would be 11. Within 3%, then E would be 0.03. In the homework, they might not use the word within. You could say how much do we need a survey to be off by 11, so the off by, within, it all has the same idea. How much off are we? Yeah. Alright. Oh, sorry. So then we go to chapter 9. And you're like, yeah, I want to go back to chapter 9. That's where we did Z-star stuff. So this one, again, there's a lot of repetition here, so you don't have to, but I don't blame you if you do. It's not a bad idea. So you got this guy. You've got this guy. Oh, sorry. Make that a T. Dadgummit. It's a T with the toupee. I don't know what the hell it is. this is the same damn formula, but one reason you might want to do this is to remind yourself that, yeah, even if you have S, you still have to do this. Right? Somebody tell me why.
Because you're not doing individuals.
Good.
you're grouping them.
S and sigma are spreads of individuals. And when I'm talking about groups, I need the spread of a group. So I don't care if I know S or sigma, I still have to divide by square root of n if I'm talking about a group besides n. And then you also have this dude. Be very careful that the bottom ones don't have hats. That's a P and that's a Q, yes? If you say so, Jeff, I understand. Well, now it looks like notes. I'm sorry. Donna. There. That's a P and a Q. Just trust me.
What was the prior one that used P and Q, but it's not
Sorry?
a Z star, right? It's a Z.
This last one?
No, up,
Here.
over.
Here.
Yeah.
Oh, that's sigma over square root of n.
Oh, that's right.
Yeah, it's the same formula that's up here.
Okay.
It's just it's not a bad idea to group. So here's the hypothesis group, right? So I don't let you put words on your formula sheet, but you can organize them whatever makes the most sense, right? Chapter 10, I'm not going to put that down yet. It's only if you want to do the extra credit.
What's 10 again?
10 was when I take two samples.
Yeah.
Oh, so don't worry, don't write that formula down. And then of course we got to chapter 12, which was all in the calculator. That's the linear stuff.
Yeah.
Chapter 11, you can write this down for sure. Write it down big old big. And that's for what?
Chi.
Oh,
To focus your chi. Kamehame. So that's
Is it over 9,000?
that's for the goodness of fit test, right? It's over 9,000.
What chapter is this? 12?
11.
Huh?
It's in chapter 11.
do you go up to chapter 9?
Sorry?
Chapter 9.
Oh, chapter 9 was hypothesis test. That's this stuff.
What was the situation for? I'm confused here because one of them has the P and Q in the denominator. The other one is P hat Q hat.
Oh, good. That's what I was asking earlier. Why are there no hats on this one?
Because you're assuming that the
Yeah.
response they give you is true.
The whole thing about hypothesis test is we assume the number that they give us in the claim is true. And we're trying to see if it leads to a contradiction. That's the whole idea of hypothesis test. So if we get into the rejection region, we're like, if you're right, look at this shit. That's basically what a hypothesis test boils down to. I think it's 7. Well, we got way up to 20. Look at this shit. You're wrong. It's by contradiction. Yes? So that's why I know P in this case. Up here-
it gets given to you in the claim.
Up here, I have no freaking clue what P is. The whole point of this is to try to get an idea of what P might be. We have no idea.
So in that bottom one, you're given a percentage within the claim, but in the top one, if you are
There's no claim.
unknown, so you can make P and Q, P hat Q hat 50-50.
No. Here we'll have P hat and Q hat from a sample we take. We just have no way to know what P is.
No, but I remember us being taught that in case
Yes.
you don't have that info.
If I'm doing this, and I don't have a preliminary
Oh.
estimate for these, yeah. This would be how big of a sample do you need? So it's possible we haven't taken any sample yet.
Oh, I
In
see.
which case I have no idea what P hat and Q hat are either. I don't know. I extra don't know
You're
shit.
not going to be in a situation where on the Z side of that, you're going to have 50-50 for P hat Q hat. It wouldn't make sense, right?
In the confidence interval?
The one right there.
The confidence interval.
Is that what that is?
This one.
Oh, yeah, because plus or minus, yeah.
Yeah, this one I gotta know what those are.
Okay.
Yeah, because I need to have taken a sample. It could be 50-50, depends on what the sample is.
I just remember running into that in the homework, and I'm like, we haven't been told percentages, and they want, and I think it was.
And that's the one, yeah. I think in the book they put 0.25 in one of the, and that's because 0.5 times 0.5 is 0.25. Alright guys, so here's the idea. So 310, we can do an example problem, get stuff kind of rolling, and then whatever else we want to do, we can do it on Monday. It's up to you guys. So do you want to do, that's always an option.
Is that the only chi-square formula we
Can
need?
you go back to the last one?
Are we gonna have these posted on Canvas?
But to this guy?
Yeah, is that the only chi-square formula that we need?
Yes.
Okay, got it.
What about the extra credit?
Now, let me do this.
Oh yeah,
Now,
what if you do want
now that everybody's got this, now that everybody's got that, if you are going to, if you did chapter 10 extra credit, then you need this formula if you want to try this bonus question out. Let's see if I remember this. Yes. Okay. Whoops. So some of you guys that might look familiar. The rest of you are like, I'm glad that doesn't look familiar.
You saw me, I tried it, and I was like, I didn't read the book, so I don't know what the next one is.
There you go. Just like young Jeff in English class, you gotta read that book, Jeff.
There's just a huge gap between how the book teaches.
So this is an extra credit problem. If you didn't try chapter 10, don't even write this stuff down because it will freak you out when you take the final and you look at your formula sheet like, what the shit is this? Don't even put it there. And then if you want to, you can put down this guy. If you do the extra credit for chapter 11, that's the one related to the Hostas test for standard deviations. Yes.
Can I call it X squared or?
Chi-square star?
Star?
Sure. We can just load this up with all kinds of stuff. Chi-square star asterisk. Huh?
Since it's extra credit, does that mean we have to do the homework?
No, it's extra credit.
So all of 11.6, no.
11.6, you don't have to do any of it.
But if I do.
If you do and you get enough right, you can get bonus points, which would be added directly to your homework grade. You could get above 100% homework grade.
Oh, okay.
Okay.
I like that.
I'll be honest.
Or if you missed some homework or whatever, it could take the place of that and kind of fill in something that's missing.
Right, with how long chapter 8 and 9 homework took, I'm ready to all
Mm.
because I still haven't finished it, so I get
I understand.
points. Each problem.
So that's something you could do a bonus section instead of something else, sure.
Is that the same for chapter 10?
Just in case I mess up.
10.2, same thing, yeah. 10.2 is the same thing.
I can still turn in.
So guys, do you want to do an example problem? We could do like a chi-square problem.
No. Oh, yeah.
I don't care.
Or can you go like P and A, probably A and B?
Oh, we can do probability, sure.
That's long.
Are these formulas gonna be on Canvas?
And then we can do one of these.
They're gonna be on YouTube
Okay.
when I post the video. Yeah,
Thank you.
And then we can do another one of these.
whatever you like. Okay. So you're asking for like a probability question?
Yeah, like using one of the P and A times B, given A, like one of those.
Sure.
Just like a refresher.
So if I knew that the probability of A and B was 0.3, and I know that the probability of B is 0.5, can somebody figure out what the probability of, let me think, yeah, A given B is?
I think 6.
Alright. Okay. So on Monday I'll have the answer key for the practice one. Yeah.
What's the
Well, I already do. It's up on Canvas, it's amazing.
Yeah, 0.6.
I have it up on Canvas.
what's the formula called for A and B again?
You got your formula sheet?
No, I don't do it in class.
Okay.
Probability of A and B divided by
Yeah.
probability of B.
So in this case, this is pretty straightforward, right?
Yeah,
Oh,
so
plug
it's
and
just
shove,
plug and
okay.
shove.
Yeah, so it's probability of A and B divided by probability of B, which is 0.6. So, if I give you this instead, probability of A is 0.78, probability of B given A is 0.3, and I want to know what the probability of A given B is. So really good play. I'm sorry. Sure.
So we have to multiply the probability of A by the probability of B given A.
These are two problems, by the way. I'm sorry. I went back up for somebody. So this is the second problem here. A really smart idea is to write the formula for what I asked you, if there is one. Is there a formula for A given B?
Yes.
Yes.
Okay, so what's that formula?
Probability of A and B divided by probability of B.
Hmm?
We have to make
A and B
probability of
and
A
A
the
are the
same.
same.
So are we able to do this? So let's see. Can we figure out the probability of A and B?
Yes.
Yes,
Okay, how do I do that?
probability of A and B equation.
Yeah.
So probability of A times the probability of B given A.
Yes. So again, you have these formulas on your formula sheet. Write a formula. Now, let me tell you one little thing about this problem. I didn't give you enough information, but I want to get to the point where we see what information you need beyond this. Write a formula for what I asked you. If there is no formula for what I ask you, write a formula for what I give you. Right? But there was a formula for what I asked. Okay. For this formula, I need to know the probability of A and B. Okay, so how do I get that? I plug this formula in. Is that cool?
Mhm.
I know both of these, yes?
Yes.
Okay. 0.78 times 0.3,
Like 2, 3, 4.
234. Okay. What else do I need to figure out A given B?
Probability of B.
Probability of B.
Do I have a way to get the probability of B?
Oh, probability. One of them where it doesn't care
Yes.
about the other.
Probability of A or B.
Do I have the probability of A or B?
No.
No.
So is your answer,
Oh, shit.
so let me rephrase the question.
Wait, isn't it probability of B given A?
No, careful.
Oh, is it 1 minus?
No,
No.
let me cut to the chase. You can't get it based on what I told you.
Oh.
So Nick, going back to what you said, what extra piece of information would I ask? So I gave you this, and I gave you this. That was enough to get the and, yes? Okay. To answer the question. This is the question, yes? Question.
You don't have probability of D?
I don't have the probability. If I give you one more piece of information, if I tell you the probability of A or B, that's why I thought maybe Nick, you were answering that question. If I told you the probability of A or B, let me see what would make sense here. Give me a second. I don't even know. Oh, okay. If I say the probability of A or B is let's see if this works, 86. I'll be really interested if that works. I think so. All right, let's see.
What's the formula for that?
The probability of A or B is
Yeah, what's the formula for the probability of A or B?
probability of A is probability of B minus probability of A and B.
Do we know the probability of A?
Yep.
Yes. Do we know the probability of A or B? Yes. Do we know the probability of B?
No.
No. Do you know the probability of A and B?
Yes.
Yes. Where'd it go? Here it is. 2, 3, 4. Jeff. So now I can just solve for probability B. Does this feel familiar? I gave a problem once a while back that you had to do a little algebra to figure it out. Subtract the 0.78, add the 0.234, yes? A little bit of algebra. A little bit of algebra. So I get 0.08, and then I have to add 0.234.
Wait, when did you solve A and B?
Sorry?
Wait, I thought that was. Oh, no, that's reading it wrong.
So then the probability B is going to be 0.314, it looks like.
Yep.
Oh my God! So, I just want to show you how these can get. I'm not going to give you one like this, don't freak out.
There was one on the homework that was really annoying. It was
I
like
like it.
5 steps.
Wait, why did you say that? What happened?
Huh? So, if I gave you one like this, I'd give you this, I'd give you this, and I would give you this. I wouldn't say, what else would you need to know? Because that's kind of like a step up.
That's stupid.
Yeah, well, not stupid, but just a little much. Okay. Can I now figure out the probability
Yes.
of A given B?
Yes.
Yes, because now I have both of these. I have A and B, and I have B. What was B? Holy shit, I made one that works. So it'd be 0.234 divided by 0.314. Whatever the hell that is.
0.745.
Sure. So when I give you a problem that I just give you values of probability statements, you write a formula for what I'm asking you, and if there isn't a formula for it, you write a formula for something I told you. And then you see if I plug what I know in, can I solve for something I need? Does that make sense? That's pretty much how those always go. That's pretty much the description of every freaking word problem in algebra. Yeah. Okay. Now the other kind of probability question I could give you would be like a table. Remember we did a lot of those tables?
That's
Alright.
the summation.
Or I can give you a problem like what's on the practice final. This one here. This is sort of like the one with the Democrats and everybody in the haunted house. Does you remember that? Okay. Do you want to still focus on probability? Do you want to go to something else?
Just keep focusing on probability.
Okay. So if you look at number, do you want to try number 2? Do you want me to make a table? Make a table? Okay.
No.
Because this one you can do on your own. I'm going to have the answer for you. The answer keys up. Okay.
Sorry, good.
So let's see. Professors, students. Yes, no. Okay. Whatever the question is. Or let me just say, don't know. Alright. So I'm a little tapped on my creative juices, so whatever the hell question I'm asking. 12 professors said yes, and 3 students said yes. 2 professors said no, and 41 students said no. And then 3 said I don't know, and 7 said I don't know. There we go. Look at that. So I just did this survey with all the people in my head. Let's see.
That's a lot of personalities.
It's crazy. It's packed. It's kind of like Doom Patrol kind of thing.
I need to watch that show.
So when I give you a table like this, I'm going to give you these blanks. And I'm going to hopefully jar your memory with what you're supposed to do. Not jar, but jog. What do I do first, even before you look at any questions I ask you? What's a good idea?
Summation of
Yeah,
columns.
get all the totals, since probabilities are all about counts of stuff, right? Be very careful that you only add this once, because this 68 should be the same as this 68, yes? Don't make it 136.
Because that should be the total of the 6 squares.
Either way you do it, should be the same number, yeah. Okay, I like it. And is it? Yes, yeah.
So you would also get that if you just added the 6 squares.
Yeah, totally, yeah. So I can ask you questions like, what's the probability that if I pick one person, I pick a professor, what's PP?
17.
PP.
Oh, 17 out of 68?
Yeah, 17 total professors out of 68 total people. And then you just do that in the old calculator and get whatever the shit. Remember how many decimals do I want for that? 4, that's right. Is anybody gonna do that? Or you guys, like, whatever, Jeff, keep going.
0.25.
Yeah, it's 0.25 because it's 1/4, yeah. Chabow! So what's probably I get somebody who said, don't know?
10 out of 68.
Yeah, 10 total said, I don't know, out of 68. Let me put this over here. Don't know, whatever.
14.71%. Oh, I'm sorry.
1.71.
You're good, you can make a percentage, I don't care. Now, when it gets more interesting is when I start asking questions like,
The one we have to exclude, the one where you don't do intersection is the other one that gets me.
okay, so if I ask you, what's the probability I get a student or someone who said no? So it could be a student, so I have to include all the students, correct?
Yes.
So I have to include all these people,
All students.
or somebody who said no. So how could I do this intelligently? 51, I've already counted somebody that said, how many people had said no have I not counted yet? 2, so then 53. Now if you do it the formula way, it would be students plus no minus whatever's both, because I counted them twice, yes? But isn't that just freaking 2?
Yeah.
So you can do 51 plus the 2 I didn't count yet. So you never have to use a formula when you have everything you need to count. Yes?
But it, I mean, it's just my own thought process, but would it be wrong to think of it as, the other one is the intersection, this is the one that isn't that, but would it, if this is a bit like, you can use the intersection technique to find where the and would be if it was student and said no, take that.
Yeah, we'll get there in a minute.
Realize
Yes.
that's what you're subtracting, and then.
Yes, cool. You can figure out the intersection and know that's what you're
My brain
subtracting.
just likes to think of it that way, it's
You're,
like,
you're good.
we're removing that number.
And then whatever the hell that is, right?
0.7794.
7794, okay. And then I can ask you what's probably that it's a professor and they said yes.
3 out of 60.
Careful.
12.
Professor. Professor. So 12 professors
Oh,
said
looking
yes.
at it.
Out of?
17. No.
Well, it's the only time the bottom changes.
Given.
I would get it.
I have to give you information so you know to exclude people.
Yes,
Right
this
now,
is-
who could it be? Could be
Anybody.
anybody, because I'm just asking what's the probability they're a professor who said yes. I didn't give you any information about it, so it could still be anybody out of the 68. There's just 12 people that match what I'm looking for.
0.1765.
Sure, man. Alright. And then the last kind of thing they're gonna ask you was probably that somebody that said no, given that they're a professor.
Then it would be 2.
So what am I given? What do I know?
No.
Professors.
That they're a professor. The
That's your job.
probability they said no. So do I know they said no?
No.
No.
So your prof total becomes your
The
denominator.
probability they said no, given they're a professor. That's why the second one is the bottom, because I know they're a professor. I'm talking about 17 people.
Yep.
Out of those 17 people, how many match what I'm looking for? 2.
Okay.
2 out of 17, which is whatever the shit.
0.1176.
Yeah, what you guys.
Whenever we get a given one,
It's starting to come back.
Oh, good.
whenever we get a given one, the one that's in the second position will become the denominator.
Yeah, given they're professors, you can literally do this.
Okay.
Everybody else gets thrown out. What's probably just said no? 2 out of 17. That's all the people I have, because I'm going to throw everybody else out. I like it. Does that yeah, let that be nice. Please let that be nice. The one that's trippy is when I give you just the numbers, and you have to use the correct formula at the correct time. That one gets trippy.
You want us to work ahead on the practice file before Monday, right?
You don't have to look at that at all, but it'd be great if you tried it out before Monday. Yeah.
It's a dumb question, I know, I just wanted to make sure, like.
Yeah, you can use the practice funnel as much as little as you want to. The answer key's up in Canvas already. Just, like always, don't just stare at the answer key, be able to try the practice
Oh,
funnel.
no, I was wondering if we were gonna do a review based on that on Monday or other things.
Oh, it'll be totally wide open, whatever the hell you guys want to focus on.
Let's do chi-square, or
Okay.
the star thing.
So let's do this. Let's do a chi-square problem, and then would everybody be cool with calling it a day? Thank you, guys. Okay. If you weren't, I would stay. Of course I would. But inside I'd be like, please.
No, but do the
No,
star one.
if you're tired too, Professor.
Oh, come on. I'm always tired, so we shouldn't base anything on that.
Oh, chi-squared star?
No, we're not gonna do an example of an extra credit.
Why?
Because
It's extra credit.
So?
So you can study it
It's
yourself
your-
if you
it's
want
your-
the extra credit.
So let's look at number 11 on the practice file.
Yeah. I'm gonna try it.
You have to try the homework, Betsy. Then you can ask me questions about it. Huh?
I have to leave,
You have to leave?
cause I don't wanna know the answers.
Oh, I see what you mean.
I wanna
I can
try
make a
it.
different problem. I can make a different problem. I don't care. Okay. So let's say I've got.
I think you, I
Yeah,
say.
cause like, we wanna try those.
Okay, I'm with you. I'm with you. I meant no disrespect. I'm so sorry.
We're like, we love your practice final so much, we wanna be surprised by it later.
Yeah.
Sure. Okay, that's good.
It's appreciation.
So now I'm tapped out on creativity. So let's see what happens.
Oh, just look at your correct practice final and just cheat.
All right, here we go.
It's cheating.
10 to 20-year-olds, 20 to 30-year-olds, 30 to 40-year-olds, 40 to 50, 50 to 60, and above 60.
Wait, there's overlap.
I don't care. Nobody's exactly 20.
That's true.
So it's really like between 10 and 20, between 20 and 30. Okay, just a quick way to say that. And let's say that I am, I don't know. It's a measure of their mental acuity. Yes.
What's that?
I don't know.
I was gonna say joint pain.
No, it's just a measure of their ability to think through a problem.
It just goes up.
Is that a dad joke?
It's an old person joke.
Oh.
All right. So I've got my observed, I've got my expect. So let's say I expect it to be uniformly distributed, and I talk to, you can do it, Jeff, 120 people. I already did 120.
Like dice rolls, 120. Here we go.
Yeah, I did. Let's do
180.
180, sure, what the hell. So talk to 180 people, I expect the distribution to be uniform, yes? So what are the two types of problems I can give you for this? Uniformly distributed, so they all get the same number,
Percentage.
or percentages. I have to give you a separate little table that has a percentage.
That confused me about percentages.
Okay. We can make this into a percentage problem.
Percentage,
Okay.
Oh,
bro.
God.
So let's say I expect,
That's harder.
oh, I need room over here. Let's say I expect 10 to 20, I'm just gonna go in the same order, yes?
Okay.
I expect 15% here. I expect, I just realized I really didn't set this up well, it doesn't matter. 20%, I expect 35% here. What's that? That's 70. So then let's say 15% and then 15%. Is that
What do you mean I expect percent here?
30, 65, 85, 100? Okay, it makes sense. Sorry?
What do you mean by here?
What do you mean?
Like I expect 35% here. What do you mean by here?
Oh, in this category, the third
Oh, it's in order.
category, yeah.
I see.
Yeah. Okay. So if I expect 15%, and let's say I talk to 180 people, how many would I expect to show up in this first category? 15%.
50% of 180.
Yeah, that's it.
Oh.
So what's 15% of 180?
Can I see the rest of the list? 15, 20, 30.
27.
27. How many would expect in the second category?
20% is
36.
36. Then 35% would actually just be adding those to 63.
63.
Yeah.
And then the other two are 27.
27 again. Did I do 1, 2, 3, 4, 5? Yeah. Let's make. All right, these people.
Gone.
They're all dead. They're all dead. Sure.
And then you're gonna give us.
They're in
answer.
hospice, their mental acuity stuff.
Yes. All right. I'm getting closer and closer to that group that I just destroyed, but I'm not there yet. So it's okay.
No, so you
Don't
just
say
freaking
that.
fractions.
We all are.
You're safe.
No, we're not. I'm not.
Yeah, we are.
You're not getting closer.
You're not getting those.
You're
Benjamin.
beyond
You're
time.
Benjamin Button.
Yeah, she's getting younger. She's gonna turn into a baby or something.
But she's gonna start hearing her voice just like me did.
Yeah.
No.
Every Joy's gonna say something when you get up.
Yeah. She gets on a
So-
You know it's bad when you wake up in the morning and go, I
Guys.
slept wrong.
Guys, so either I tell you it's uniform, and then you divide the total by how many categories, or I give you percentages, right? The observation I have to just tell you.
Oh, okay.
So, right, so let's say I observe, I don't know.
Wait, sorry, for non-percentages, isn't there more to that formula? You're not just dividing by, it's like n minus 1 or something, there's a whole lot.
No, dear God. It's just straight up, I expect this many of this many, so I can just do the time.
No, for percentages I know, but for non-percentage problems, you would just take your, you're expected, you just divide the total number.
Yeah,
of
and it
whatever
could come out to be decimal if it doesn't go in even.
Because it's
Of course.
uniform.
Yeah,
And that's normal? Okay.
that's fine. Yeah. Alright. Let's say that I observe 30 here, I observe 38 here. Oh shit, I gotta make this work. I observe 58 here. Let's see, plus 3, plus 5. Okay. And then I observe, wait. Okay, that's right. 29 and 25. Okay. So observations, I'm going to just tell you. The expected one you have to fill in. Either it's uniform or it's percentages. You can calculate either one. And now is when you just start doing the calculations you need. The formula needs the sum of observed minus expected divided by E. Good Lord, check how many lines does an E need. So I do observed minus expected squared. So this would be what? This would be 3 squared,
9,
2 squared,
4,
5 squared,
25,
2 squared,
4.
2 squared, 4. And, you know, I always desperately want you to understand the idea behind why we're doing something. We divide by E to get an idea of the relative size of the difference.
For this table, is
Yes.
it like the XP of X table where we need to memorize like what goes in each list?
Yeah, so let me be careful. I like that you asked that question because I think I am going to put these on there just because
You are?
we haven't really messed with these much. Normally I leave these blank.
That just means the XP of X ones will be blank, and it's been so long since we've done those.
Well, those will be blank for damn sure, yeah. Because they were blank before. So now I just take, and again, you can do all this in the list if you want to, but now I take every observed minus expected squared and I divide it by E. So this is easy.
1/3.
So that'd be 0.333 blah blah blah. Then 4 divided by 36 is also nice. 1/9. 25 divided by 63. I have no idea. Wait. 0.4? 0.39?
Yes.
397. Okay. And 4 over 27 is roughly 0.15.
148.
1/4. What?
148.
Damn it. I get close and
Close
then I
enough
try
for
to
government work.
budget. Yeah, sure. And that's where I work, so it's okay.
Exactly.
And then you add this stuff up. So let's see, 4, 4, 4, 4, 4, 4, 4, 1. I don't know. What did I
Bottom
do?
one's 1/4, right?
Thank you, yes. One, 1041, 159, 1137.
Yeah.
Okay.
1137.
That's good.
1137.
Now, we haven't messed with this much, but if you remember your chi-square chart at all, is that a very big chi-square?
No.
Nope. But let's see. Let's just go with it. What if alpha was 0.19? What's my degrees of freedom?
5.
4.
4.
1, 2, 3, 4, 5, because I killed the last people.
Oh,
Yeah, K
Don't
minus.
tell anybody.
4.
Categories minus 1 would be 4. So can you look on this chi-square chart, see what your rejection region chi-square would be? Did you notice that goodness of fit is always a right tail test? Because I got to be far away from the 0. Okay. So if I look up 0.10, 4 degrees of freedom, what do you get?
7.779.
Jesus, we're getting close.
And we got 1.1. Yeah, so we definitely did not show evidence that these don't follow this pattern. Right? And to be really, I really want this understood. This was a sample we took, yes? So we're looking for evidence that the population follows this pattern, or evidence against that. So sure, these were different, but any sample is going to be different. So really it's all about, is it different enough?
And
And
this
this
is
was nowhere near different enough.
definitely like
Yeah,
evidence.
they were really close. They were really close.
You always want to be
I was trying to make it
outside-
easy to do in my head, to be honest, huh?
You always want to be outside of the chi-score that you get.
To show evidence that the population we got this from does not follow what was expected, we have to be outside of here.
And we're
Because what
also
would 0 mean again? If I get a chi-square is 0, what would that mean? The only way to get 0 is if these are
the same.
the same. So that would be desperately not enough evidence that they're different.
Right.
So I'm fighting against it being no different, which means I have to not only be different from 0, I got to be different enough from 0.
How do we know that our claim wasn't that they're similar? It's just how it was worded at the beginning.
Oh, yeah, depends on how I word it, but I don't know if I even worded. So the whole idea here is, does the population that's come from follow this pattern? If you don't make it in there, it's not evidence against it. If you do make it in there, it's evidence against that they follow that pattern. Yeah.
Well, we just did was chi-squared star, right? Is that what-
Yeah, chi-square star. Because this one is the chi-square that we get for the rejection region, right?
So what comes from the chart?
So our star is the one that we calculate, yeah.
Wait, what?
Just like Z-stores, Z-stores.
I'm
Wait,
not worried
Go
about
up, go up.
Go to Z-stores, buy a Z. What's up?
it. What scares me is, the frickin', the claims, I always get those wrong.
Okay.
Like, the math is fine, and then I get to the wording part, and I'm like, what are we rejecting?
Some that we get from the table is the star, and then the degrees of freedom is the barrier.
No, it's the other way around.
Is the rejection region, no? This is the rejection region, just like when we did Z-scores. How did I get a rejection region? Didn't I give you an alpha and you looked it up?
Yeah.
That's your rejection region. How'd you get the star? Didn't you actually calculate it? Okay, so this thing you calculate is your star. And the reason I call it a star is just because you put a little star on it so you see where it fell,
Yeah, yeah.
right? Okay. Because I have two chi-square sources here, don't I? This one and the one I didn't write. This one. So I just wanted a way to differentiate between the two. I think the book would call this chi-square critical, because the book is weird. Okay, so try the one out that's on the practice final. We can talk about that on Monday. All right, guys.
One more week.
I have a question.
Yes.
What's the difference between